Projective Geometry, Volume 1, by Oswald Veblen and John Wesley Young. Section 3, Ideal Elements in Geometry. The miniature mathematical science, which we have just been studying, suggests what we must do on a larger scale in a geometry which describes our ordinary space. We must first choose a set of undefined elements and a set of fundamental assumptions. This choice is in no way prescribed a priori, but on the contrary is very arbitrary. It is necessary only that the undefined symbols be such that all other elements and relations that occur are definable in terms of them, and the fundamental assumptions must satisfy the prime requirement of logical consistency and be such that all other propositions are derivable from them by formal logic. It is desirable, further, that the assumptions be independent, and that certain sets of assumptions be categorical. There is, further, the desideratum of utmost symmetry and generality in the whole body of theorems. The latter means that the applicability of a theorem shall be as wide as possible. This has relation to the arrangement of the assumptions and can be attained by using, in the proof of each theorem, a minimum of assumptions. Symmetry can frequently be obtained by a judicious choice of terminology. This is well illustrated by the concept of points at infinity, which is fundamental to any treatment of projective geometry. Let us note first the reciprocal character of the relation expressed by the two statements: a point lies on a line passes through a point. To exhibit clearly this reciprocal character, we agree to use the phrase "a point is on a line is on a point," to express this relation. Let us now consider the following two propositions. 1. Any two distinct points of a plane are on one and only one line. 1 prime. Any two distinct lines of a plane are on one and only one point. Either of these propositions is obtained from the other by simply interchanging the words point and line. The first of these propositions we recognize as true without exception in the ordinary Euclidean geometry. The second, however, has an exception when the two lines are parallel. In view of the symmetry of these two propositions, it would clearly add much to the symmetry and generality of all propositions derivable from these two if we could regard them both as true without exception. This can be accomplished by attributing to the two parallel lines a point of intersection. Such a point is not, of course, a point in the ordinary sense. It is to be regarded as an ideal point, which we suppose two parallel lines to have in common. Its introduction amounts merely to a change in the ordinary terminology. Such an ideal point we call a point at infinity, and we suppose one such point to exist on every line. The use of this new term leads to a change in the statement, though not in the meaning, of many familiar propositions, and makes us modify the way in which we think of points, lines, etc. Two non-parallel lines cannot have in common a point at infinity without doing violence to propositions 1 and 1 prime. And since each of them has a point at infinity, there must be at least two such points. Proposition 1 then requires that we attach a meaning to the notion of a line on 2 points at infinity. Such a line we call a line at infinity and think of it as consisting of all the points of infinity in a plane. In a like manner, if we do not confine ourselves to points of a single plane, it is found desirable to introduce the notion of a plane through 3 points at infinity, which are not all on the same line at infinity. Such a plane we call a plane at infinity, and we think of it as consisting of all the points at infinity in space. Every ordinary plane is supposed to contain just one line at infinity. Every system of parallel planes in space is supposed to have a line at infinity in common with the plane at infinity, etc. The fact that we have difficulty in presenting to our imagination the notions of a point at infinity on a line The line at infinity in a plane and the plane at infinity in space need not disturb us in this connection, provided we can satisfy ourselves that the new terminology is self-consistent and cannot lead to contradictions. The latter condition amounts, in the treatment that follows, simply to the condition that the assumption on which we build the subsequent theory be consistent. That they are consistent will be shown at the time they are introduced. The use of the new terminology may, however, be justified on the basis of ordinary analytic geometry. This we do in the next section, the developments of which will, moreover, be used frequently in the sequel for proving the consistency of the assumptions there made. Projective Geometry, Volume 1. This book was written by Oswald Veblen and John Wesley Young. It was published by Blaisdell Publishing Company, London, 1910, and is now in the public domain. It is read by Jim Renholt, with programming and illustration by Jim Renholt, 2019. Thank you for listening.